Hello folks, and thanks for joining me once again. We're looking at question number 22 on the 2006 Grade 8 Gauss paper. So what does question 22 have for us? The 8 people at a party shook hands exactly once with each other, with each of the others, before the 9th person arrived. Okay, so there were 8 people at a party, and everybody shook hands with everybody else exactly once. The 9th person then shook hands with some of these 8 people. Some, maybe that's what we have to figure out. A total of 32 handshakes took place. With how many people did the 9th person shake hands? And we got 3, 4, 5, 6, or 7. Okay. So, what should we do here? Well, what I'm going to do is I'm going to break the handshakes up. After I get myself a fresh piece of paper, of course. So I'm going to break up these 32 handshakes. So 32 handshakes. I can separate those into 2 numbers. The number of handshakes. So the number of handshakes the 9th person was involved in, plus the number of handshakes before the 9th person arrived. Before he got there, everyone shook hands with everybody else. In theory, I should be able to figure out this number. I know this number is 32, and that would leave my answer. Okay? You know, be it 3 or 6 or 4 or something. Okay. So now we've changed the problem. Now I just need to know how many handshakes occurred amongst the 8 people. Well, everybody shook hands with everybody else exactly once. And sometimes, not saying all the time, but I've seen handshake problems before. And you get a sense of how to do them. Now, if this is your first time dealing with, how many handshakes took place with this many people, we're going to walk through it slowly. But and I'm going to look at some smaller cases first and then generalize to 8 people. But it's something you might want to remember the technique for. Handshakes do pop up, especially if you're going on to university math and you want to do something like combinatorics. This is great for combinatorics. So for a moment, let's ignore 8 people and let's just say we had 3 people. We'll call them A, B, and C. How many handshakes took place if everybody shook everybody else's hand exactly once? Well, it takes 2 people to do a handshake, so we might label our handshakes AB, AC, BC. Now, you could have BA, but that's A and B shaking hands, just written slightly differently. So that's not a new handshake. And in fact, these are the only handshakes you can have. So what you might ask yourselves, well, how many people does A shake hands with? He's got B or C he can shake hands with. That's 2 handshakes. Now, how about B? We could count him shaking hands with A, but we already did that up here. And so B only has C left to shake hands with. And then C, well, C can shake hands with A or B, but we've already counted both of those cases. Okay, so we get 2, 1, 0. We add them up. We get a total of 3. And here are our 3 handshakes. Now, suppose I had 4 people. Now, A, B, C, and D. And we might again say, well, let's first count the number of handshakes involving A. A could shake hands with B, C, D. That gives me 3 handshakes. Now, who can B shake hands with? Well, he could shake hands with A, C, or D, but the A-B handshake is already counted. Handshakes are not one-sided. It's not A shaking the hand of B and then B shaking the hand of A is separate. A handshake is mutual. The hands meet, they shake a little bit, and that's how it goes. It's not like A kissed B on the cheek. That's not reciprocal. It's not the same as B kissing A on the cheek. That would be a different situation. But handshakes are two-sided. You shake my hand, I'm shaking your hand. So that means B, we can only count the shake with C and D. C only we can count with D because we've already counted the CB handshake and the AC handshake. And D, well, all the handshakes that D was going to have been accounted for. The C handshake, the B handshake, and the A handshake, that's 0. So we add those up, 3 plus 2 plus 1, 0, 6. Okay. Now we might be able to jump up to 8 people. And if you're not comfortable with that, try working out 4 people. Call them A, B, C, D, and E. And ask yourselves, well, how many handshakes is A involved with? A, B, C, D, E. Okay, H is where we want to go. So A, well, how many handshakes can they do? B, C, D, E, F, G, and H, and that's 7 handshakes. Notice that the first guy we choose has the number of handshakes less than the number of people because he can shake hands with everybody except himself. So that's all but 1 people. And then B, well, B can shake hands with not themselves and not A because that's already counted for, so that leaves 6. So 8 people shaking hands is going to result in 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1 plus 0 handshakes. And you might have seen something like this before. It's the sum of the first 7 numbers, some of the first 3 numbers, some of the first 2 numbers, because this 0 at the end doesn't really count. And so if you had n plus 1 people, so we'll come back to actually calculating this out, but let's finish our handshake theory. If you have n people shaking hands, then you're going to have a sum of n minus 1 plus n minus 2 plus n minus 3 plus 2 plus 1, and then the plus 0, but we don't really count the plus 0. Okay? So this is the sum of 1 plus 2 plus 3 plus all the way up to a certain amount. And this has a nice quick expression. If you add the sum of the numbers from 1 plus 2 all the way up to plus k, there's an expression for this, and these types of numbers are called triangular numbers. There's an expression here, n times n plus 1 over 2. Just matters what's your last number, what's your biggest number. Well, in this situation, we're doing 1 plus 2 plus 3 all the way up to n minus 1. So wherever we see k, we put n minus 1. And we can simplify that, because n minus 1 plus 1 is just n. So this will be the total number of handshakes. And if I were to plug in 3 people, I'd get 3 times 2 over 2, which is 3. And what happened when we had 3 people, A, B, and C? We had 3 handshakes in total. 4 people, you get 4 times 3 over 2. So that's 12 over 2, 6. And we had 6 handshakes. How about for 8 people? So for n equals 8, we get 8 times 8 minus 1 over 2. 8 times 7 over 2. 56 over 2, 28 handshakes. And if you calculated the sum that we had over here, 7 plus 6 plus 5 plus, this would be 28. You start to get to know these numbers after a while. 1, 3, 6, 10, 15, 21, 28, 36. These are called triangular numbers. And there's a whole bunch more you can learn about them, but I'm not going to dwell on it right now. So we know 32 handshakes is the number that 9 shook, plus the 28 handshakes that already took place. We rearrange and we get 4 is the number of hands that the 9th person shook. I think that was B because it went up. It was 3, 4, 5, 6, 7, right? Yeah, so it's B. Okay. So it took us a little while. I mean, you probably could have, if you wanted to do it quickly, just written out all the handshakes, but it's hard to make sure you don't miss one, so do it methodically. Do number of handshakes A does, number of handshakes B does, C, and so forth. And you know it's got to be less than 32, so that way you can certainly identify if you made a mistake. And that would be a faster way to do it, but now we sort of have a general theory of handshakes that we can take forward, and if you haven't seen triangular numbers, now you have. You feel free to look them up and learn more about them. Handshake problems, now we've seen those, and so if those ever pop up again, it's rare on Waterloo contests, but it does happen more as you get more advanced into math. Okay? And then we've also seen that nice sum of the first k natural numbers. I'm not going to dwell on that. There's a cool proof for it, but we're sort of limiting ourselves to contests here. And that's question 22. Join me in the next video for question 23.